Hello everyone. In this video, we are going to discuss the different soil characteristics from the irrigation point of view. So let's start. So when we want to study the soil characteristics, the first question that comes to our mind that what is this soil? So this soil is the material which is obtained upon the weathering of the rocks. So if you look at these type of rocks, so this is representing the rocks, and when there are different agencies which are acting upon the rocks, they tend to weather the rocks. That means they tend to erode the rocks. Now that erosion or the disintegration of the rocks, that may be due to different number of agencies, and depending upon the type of agency which is causing the weathering of the rocks, this is classified as the different type of the soil. So this phenomena that is known as the weathering of the rocks. So in a soil cycle, let's say this is a rock which is present earlier stage. Upon the action of the different agents, this will be weathered and will be transported to different places. Let's say after the disintegration, this rock will present in this form, and after that, after disintegrating and transporting to another place, it will be collected at a certain place, and that is known as the upheaval of the soil mass. And when it is collected up to a certain level, it again forms a rock. So that means this is a cycle which evolves around it. So this soil is the material obtained after the disintegration of the rocks. Now the agencies which may cause this disintegration, that may be either the air or the water or the glaciers or the lake or the sea water, or there may be n number of agencies which may cause this. So this soil which is formed after the disintegration due to the blowing air or the wind, that type of soil that is known as the alkaline soil, or depending upon the type of minerals which are present, this is also classified as the lowest soil. For the water, when we are talking about the water, so we are specifically talking about the river water. So when we are talking about the water, we are specifically talking about the river water. So the soil which is formed because of the deposition of such river water, that is classified as the alluvial soil. If the soil is transported by the glacier or the avalanche, that is known as the talus soil. If the soil is deposited because of the lake water, that is classified as the lacustrine soil. And because of the sea water, the soil which is deposited, that is known as the marine soil. Now all of these are the transported soil. That means the weathering agency that is eroding or disintegrating the rock, along with it, it is transporting the eroded material. So that's why such type of soils are known as the transported soil. But if the soil is remaining at the place of its origin, that means after the disintegration of the rock is present at its original position itself, that is known as the residual soil. So if the rock is present at this position only, this will be known as the residual soil. That is the basic types of the soil that we come across usually. Now this alluvial soil and the marine soil, they are usually rich in the nutrients, and that's why in India mostly these type of soils are used for the irrigation purposes, or it would be rather right to say that these type of soils are used to cultivate the different type of crops. Now, if we look at this soil is a three-phase material. That means within this soil mass, let's say if we have collected this soil mass, then within this soil mass there will be different solids which will be present. Along with these solids, there will be certain amount of water which will also be present, and the remaining portion will be covered with the air. Now this is represented in the form of a diagram which is known as the three-phase diagram, which is representing these solids, then the water and the air. Therefore, the soil which is present below the ground level, which is providing the root zone to the crop, it will be having certain amount of water. That is known as the root zone soil water. Now this water that serves the following useful functions in the process of the growth of the plant. That is, it germinates the seeds, it generates and it starts all types of chemical reactions, all types of biological process that occur during the life cycle of the plant. Absorption of the plant nutrients through their aqueous solution, because that is transported by the plant itself. Then the temperature is controlled with this water. There is certain help in the tillage operations which is carried out with the help of this water, or the washing out or the dilution of the salts, which we have earlier studied as the leaching process. So that is also done with the help of this root zone soil water. This leaching was done externally, but if enough soil water is available at the root zone, then it would be possible to wash out the salts by the crop itself. Now the soil water that is divided into these three categories, which are mentioned as the gravitational water or the free water. Second one is the capillary water, and the third one is the hygroscopic water. Now as the name itself suggests, the first one is the gravitational water. So let's say this is the certain crop which is growing. This is the root zone of the plant. So if we apply the certain amount of water, the certain portion of the water which is applied, it will be flowing under the gravity and it will be seeping into the earth, and it would not be stored in the root zone of the plant, and it will drain and will be added up to the water table level. Now such water is not useful for the growth of the plant, and that drains right through. The second type of the water, that was the capillary water. Now the certain amount of water that will be sucked up by the roots of these plants because of the capillary action, and that water that is stored within the root zone, and this is held by the plant in the micropores which are present in the root zone. So this is the available water which the plant can absorb through the roots, and this water should be available above the wilting point of the plant. That means the minimum water level below which the plant would not be able to survive. The third type of water, that is known as the hygroscopic water. That means which is resistant to the water. So if this hygro term is present, that means the water would not be adhered to the root zone. This water, the plant are not able to extract this amount of moisture from the ground. That's why this is below the wilting point. That is all types of the soil water or the soil moisture which is present. So that means in totality only the capillary water is useful for the growth of the plant. Then the next property is the depth of the soil. So importance of having an adequate depth of the soil for storing the sufficient amount of irrigation water and providing the space for the root penetration, it cannot be overemphasized. Because let's say this is the again the crop and this is the root zone of the plant. So if we are having the soil depth, let's say up to this level only, below this there are the rocks which are present, then obviously there would be a problem for the root to grow beyond this level, and the water will only be stored in this region only, and that too will be percolating down this because we are having the pervious medium. So the shallow soils which I have shown you, they require more frequent irrigations because the water will be utilized very quickly, or else it will be going down to the ground, and it cause excessive deep percolation losses when these shallow soils they overlie, when they are present over the coarse textured, that means the rocks, or the highly permeable sands and the gravels, through which the number of voids or the volume of the voids that is higher. In that case we would require higher amount of water to irrigate. On the other hand, if the deep soils are present, the same condition, the same type of crop having the same depth of the root zone, but let's say if this is the soil depth which is available, that means we require this much only, and we are having this depth available with us. Therefore, for the deep soil, the requirement of the irrigation that would be less frequent, which would permit the plant to penetrate deeper, and it would provide for the large storage of the irrigation water, because this entire area would be used for the storage facility of the irrigation water. Now as a result, actual water requirement for a given crop, that would be more in case of the shallow soils, because these shallow soils they would require frequent irrigation. So let's say if this requires only this volume, entire volume, that is 10 units, and this entire volume is 20 units, but this deep soil that require the irrigation only 5 times, but this shallow one that require the irrigation, let's say 12 times. So in that case the total amount of water that would be required in shallow soils, that would be 120 units, while in case of deep soil it would be 100 units only. So the actual water requirement in case of these shallow soils, that is more than the what is required in deep soils, even though the amount of water that is actually absorbed by the crop, because the crop is the same, so that means the water which would be used by the plant, that is same in both the cases, but the difference is because of the unavoidable water losses at each of the irrigation. So that is the difference between the type of the soil or the required depth of the soil. So that completes the soil characteristics from the irrigation point of view. In the next video, we will start the hydrology and we'll study the hydrology concept and the hydrologic cycle. Thank you.